Hello and good morning. Today we're going to be talking about math review of some certain topics. Some of these you may have seen before, but it may have been a while. So let's go ahead and take a bit of a review. First off, we want to go ahead and review the rules for signed numbers. Signed numbers are also called integers. Remember, when you have like signs, you are supposed to add the absolute values of each number and keep that sign. So we would add the 7 and the 1 here to get 8, and it would be a -8. Final answer. When you have different signs, you will subtract the absolute values and keep the sign of the larger. So in this example, we subtract 10 minus 8 to get 2, but the answer is a -2 because the 10 is larger. Remember now, when you have a double negative, you always end up with something positive, as in this example. It asks us to either add or subtract, and basically, as you've just seen, those sign rules are the same. But anytime you have a negative right together, that means the opposite of a negative. There's no number in between. You can go ahead and drop that parentheses and change that to positive. So we pretty much think of this as -5 plus 17, which would give us 12. Remember, I would have to subtract here, and I keep the sign of the larger. You can also use a calculator if you have one handy. We recommend the TI-30X because it's very user-friendly and has a lot of cool fraction features. Now, when it comes to multiplying or dividing the signed numbers, the rules are the same. If you have two of the same signs, whether you're multiplying or dividing, you always get a positive answer. You've probably heard a negative and a negative gives me a positive. Well, that's only true in multiplying or dividing. So here, -24 divided by -6 would give me +4. But if the signs are different, as in this last example, 4 times -8 will give me -32. That would be a negative answer. Another math technique that you need to be reminded of is how to work an exponent. In this example, you'll see that the base is 3 and the exponent's 2. That means we multiply the 3 times itself twice, and 3 times 3 equals 9. When it comes to evaluating formulas, here's an example of one like this. The formula is D equals RT. Some of you may not recognize it, but it's the distance formula. Basically, you need to be able to take that 60 for the R, the rate, and substitute that in. Take that 7 for the time, the T, substitute that in. When I substitute in values, I normally use parentheses to substitute those. Then, since there's no sign or symbol between the R and the T, you would multiply. So 60 times 7 would give us the answer of 420. That would be the final answer. Now, when it comes to fractions, a lot of people tend to avoid those, but we just want to review the basic concepts. And again, if you have a user-friendly calculator, today many of the calculators will handle these fractions for you in your application problems. In this particular example, we would want to reduce this fraction to lowest terms. That means we want to keep dividing the top and the bottom, numerator and denominator, until we get it to lowest terms. I notice that 6 will go into each of these, and if I divide both the numerator and the denominator by 6, 48 divided by 6 is 8, and 54 divided by 6 is 9. Now, 8 and 9 have no other common divisors, so we call that lowest terms. When it comes to multiplying fractions, you actually multiply straight across. So 4 times 1 is 4, 5 times 3 is 15. That's already reduced to lowest terms. So that would be my answer. To divide two fractions, I always tell students, remember the phrase keep, change, flip. That means that we keep the first fraction the same, we change the divided by sign to multiply, and we flip the second fraction. When you flip that, it's called the reciprocal. Then you would multiply straight across. So 5 times 10 gives me 50 in the numerator. 12 times that -3, or if you just wanted to pull the negative out in front of the bar, that would give you 36 on the bottom, but that whole fraction is negative here. Notice that it's not in lowest terms because these are both even numbers. If they're even numbers, then divide by 2. 50 divided by 2 is 25. 36 divided by 2 is 18. 25 and 18 don't have any other common divisor. Don't forget to carry over that negative sign, because remember, positive times negative is negative. So my final answer reduced is -25/18. Now, when it comes to fractions, a lot of times you'll have an application type problem. Here we have a situation where you might have a countertop of some type on a cabinet, and it's made of 5/8 inch particle board. And it's going to be covered with a 3/16 inch laminated plastic. So we're going to add another depth of plastic on top of that particle board. It says what width of metal edging is needed to finish this off. Well, you have to get the total depth of the kitchen counter to figure that out. So you have to add up the depth, the width of the particle board and that of the laminated plastic to figure out how wide that metal needs to be. So we need to add these two fractions. Remember, when you add fractions, though, you need something we call the LCD, which is least common denominator. When you look at 8 and 16, always look at the larger number and see if that will work as the least common denominator. If it doesn't, you could multiply the two denominators. But here I notice that 16 is a multiple of 8. So I could just convert the first fraction into 16ths, keeping the second fraction as it is. Now, to convert that first fraction, I would have to multiply both the denominator and the numerator by 2. 8 times 2 on the bottom would give me the required 16, and 5 times 2 on the top would be 10. Now, after you get the common denominator, you just keep it in the answer, and you add the numerators. So 10 plus 3. That's going to give me 13/16, which is in lowest terms. So that metal edging has to at least be 13/16 inches wide. Now let's go ahead and convert fractions, decimals, and percents. A lot of times this is done more easily with a calculator. First, I want to change the decimal to a quotient of integers. When that phrase is used, that means change it into fractions. Whenever you're changing something into fractions, you need to remember the place value behind the decimal point. If this is the ones place in the decimal point, there are several place values behind the decimal. The first place is called the tenths. The second place is called the hundredths. And that last place value is called the thousandths. And then it goes on to infinity as well. Now, since this is only one place behind the decimal, I could write that as 6/10. That is the fraction or quotient of integers. Now, 6/10 must be reduced. They're even numbers, so I'm going to divide both by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. That would be my final answer reduced. Now, here we're going to change this fraction to a percent. So what you need to do is literally divide the 3 by the 4. This can be done in a calculator, and you will get a decimal answer, or you can go old school and say 3 divided by 4 and just take that out as far as it will go. 4 goes into 37 times, that'd be 28, and I subtract. 4 goes into 25 times, that'd be 20, and I subtract 0 remainder. So I get 0.75. If you put it in a calculator, you normally type in 3 divided by key, 4, and then the equals key. That will also give you 0.75. This is the decimal, but we want a percent. To change a decimal to a percent, you just move the decimal point over 2 places to the right, and you add in the percent symbol. So the fraction 3/4 is equal to the decimal 0.75, which is equal to 75%. Now here you already have a decimal and you simply want to change it to a percent. Just move that decimal point over 2 places to the right and put the percent symbol.